Okay, just when we start getting the hang of these proportions, we're going to change over to means. Same as the last chapter. First part were proportions, second part is means. Make sure that you take a look at your reference, and the same exact things are going to apply. We've got our standardized test statistic equals. It's the same type of method that we're going to use over here. Confidence interval, it's the same type of thing. Over here, I don't know if you notice sample proportion, and it has standard deviation of the statistic. It has written down there. Sample mean, that's just from the front side of this page. So we're going to be using this formula whenever possible. So if I look at this problem, I don't want to write anything down just yet. I want to go over a few things about means. Means are not going to use the z-table to find a z-score. Means are going to use a t-table, which is different than what we've been doing. A t-table involves degrees of freedom, and we need to know what confidence interval we're looking for. So if we look at this problem right over here, I don't know if you remember from the problems before, degrees of freedom is usually n minus 1. So for this, we've got a sample of 250 students. That would be, our degrees of freedom would be 250 minus 1. So 249. We're also going to be doing for this problem a 95% confidence interval. So I'm going to switch over to the t-table and show you how to read it. So the t-table looks very similar to the z-score table, but notice the z-score would have this whole bottom part shaded. The t-score is going to give you the probability for the upper tail. So they do give you a picture for it, but it's the opposite of what you may think. This table is actually easier, I think, than the z-score table. Over to the left, you'll see all the degrees of freedom. Same type of thing over here. Your probability is going to be your critical value. Your t-value is going to be here. Your probability is up here. So it's kind of the opposite of the z-score. These are the numbers, the t-values that we'll be using. So for our problem, let's look. Degrees of freedom, and that's what DF stands for. We said we were asking 250 people, so 249 degrees of freedom. If you look at this table, 249 is obviously not going to be on here. So you want to look for the smallest number as close as possible to 249. So our 249 is going to be somewhere between 100 and 1,000. Which should we use? Well, even if we were closer to 1,000, we want to use the smaller one. So from 249, we want to use the 100 section. And that line is the one we want to stick with. Now also notice, so we've got this whole line highlighted here. Yeah, that might not work nicely. Okay. In addition, at the bottom, it gives you your confidence level. So if you're looking for a 95% confidence, 100 degrees of freedom, that's the number we're going to use as our t value, which is our critical value for this. It's not a z-score value, it's a t-score value. So it does work out a little bit easier. If you look up at the top, that's also at 0.025, which is 2.5% for the upper tail, 2.5% for the lower tail, which means 5% total, 95% in the middle. So they give it to you in two different ways where you're finding confidence level, 95% confidence level. 249, we'd want to use 100. That's the closest, basically closest without going over, is 100, and that would be our t-value. Otherwise, everything is solved the exact same way we would normally do a confidence interval for proportions. So just to kickstart this problem, and we're not even going to solve it today, we'll solve it for the next one. what's the population or perimeter of interest, we're trying to find where the true mean is. It's the same as what we were doing before, finding the true proportion. We want to find the interval at which we can be pretty confident that it will lie in between. So for this question, it's trying to find when you look through, the mean time that students at this school spent doing homework in the last week. The population that we're talking about are these high school students. Checking the conditions. Same as what we had done before, making sure that it's random. Does it say somewhere that they pick people randomly? Yes. Also making sure, now for this, we don't have this NP is greater than or equal to 10. We don't have that because we don't have a P last I checked in this problem. There's no proportion. We still have this 10% rule to checking for independence. In this very large high school, do you think that they picked 250 people, could there possibly be more than 10 times as much? 2,500 students, sure. In a really large high school, I would assume there could be probably that much. The other thing, does it say that it's approximately normal? That NP rule did not fit, so we can't use that. In this, it doesn't say anywhere that it's approximately normal. So without the information of it being approximately normal, you have to make sure that you take a sample size of 30 or greater. Did they do that? Yes, they took 250 students, so all the conditions are there. How many degrees of freedom? 249. What was the T value that we noticed from the other table? It was 1.984. Okay, so the next thing we're going to be doing is actually finding the confidence interval.